Here, Maddie's gonna start us off if you're ready.
Awesome. Hi, everyone. Maddie Muxley. I'm the Soil Moisture Water and Snow Program Manager at the Yampa Valley Sustainability Council. We're very excited to host our second annual student research session, and our first presentation is going to be from Rachel Sandy. Rachel is going to be presenting on hopefully I got that order right.
Oh, no, sorry, did I mess up? Yeah,
No, you're totally
no.
Okay, perfect. And Rachel is going to be presenting on the work that she did last summer with the Yampa Valley Sustainability Council and the Center for Western Northern Water. And go right through.
And also when you go ahead with the slides, just use this arrow, these two. Thanks.
Could you open with a little description of yourself and what you're studying and all?
Definitely. Well, I'm Rachel Santee. Oh, I don't want to stand in the sun over there. I'm studying sustainability studies and outdoor education here at Colorado Mountain College. I love to be outside. I'm an avid backpacker and hiker. And of course skiing, which I didn't know until I moved here. Yeah, the outdoor education program here really is a nice pair with the sustainability studies program, kind of getting the students involved and people, youth connected with the environment, which is I think we're all connected to it in a very meaningful way, because we're all passionate about climate change and wonderful things like that. So that's kind of how I got connected here. But yeah, so in the summer of 2021, I was an intern with the Yampa Valley Sustainability Council and Center for Western Weather and Water Extremes, and a student here. I was able to work on a project based in Steamboat Springs, Colorado. And then here's a picture of the Yampa River, which we talked about a lot yesterday. A magical river. And so my project was aimed to better conserve and manage water in the midst of a severe westerly drought. And my project title is, or was, a sub-basin comparison of soil moisture to inform meteorological station location. And my mentors were Anna Wilson, Madison Muxworthy, Nathan Stewart, Michelle Stewart, and Nicole Pepper, who are very involved with this project right now. Cool. Water in the West has become a huge issue for the status of soil moisture in watersheds, largely dictate what portion of rainfall or snowmelt contributes to stream flow or groundwater recharge, which led me to my research question: how do in situ soil moisture measurements vary at a sub-basin scale, and what landscape level parameters potentially influence that variability? So to the left is a map of the Upper Yampa River Basin, outlined in gray right here. I didn't learn GIS until after this project. Circled in red is my first site location in Buffalo Pass, or up Buffalo Pass, where I took 3 soil moisture transects in between snowtell sites labeled A and B. Circled in purple is my second location, the Flat Tops Wilderness area, or right before the Flat Tops Wilderness, actually. Labeled C, where I took 3 soil moisture transects located near another snowtell site. To the right is an image of my transect line, starting in the catchment zone, going upslope away from the catchment zone, measuring volumetric water content at 4.8 and 8 inches. So I did that at 10 feet intervals until 150 feet. The purple box represents the TBR 150 soil moisture meter, which measures volumetric water content through time domain reflectometry, I think, and it kind of does that through these poles or probes. And then these 2 graphs show the same comparison of in situ observations of volumetric water content along the y-axis and distance along the transect line going away from the catchment zone upslope. So you can see that volumetric water content was higher in the catchment zone, and as you go away from it, it decreased. In blue, volumetric water content at 4.8, and in red, volumetric water content at 8. As we move away from the catchment zone, it decreases in the grass and shrubland with no overhead tree canopy. As we move away from the tree canopy, volumetric water content decreases. The second graph, the start of the transect again in the catchment zone, higher volumetric water content. As we move into the shrubland with no tree canopy, volumetric water content decreases again. I want to note that the jump in volumetric water content circled in blue is the same volumetric water content as the start of the catchment zone. The vegetation exposed is evapotranspiring at a much faster rate, losing water at a faster rate. Results are showing that there is notable relationship between vegetation and water availability. That would be a very beneficial piece of data for water managers to use in our valley. Oh yeah, and then this like weird gap is just because there was rocks in the soil, so couldn't really push it down without breaking the instrumentation. And then now I want to bring your attention to soil moisture and precipitation. Precipitation falls from the sky and interacts with the soil, where water is often stored or lost. Listed to the left is an average volumetric water content from 3 sites at 2 different depths. To the right is precipitation data from in red Buffalo Pass and in blue Flat Tops. And the stars indicate which days I was there. And I obtained this data from the SNOTEL sites kind of near these transect lines. The data shows an opposite correlation between volumetric water content in the soil and precipitation measured from SNOTEL sites. And then I think, are we doing questions now or is that?
Sure.
Cool. That's my question.
What do you think the interpretation is of the precipitation and soil moisture relationship?
Well, I think that it kind of depends because I didn't really get right next to the SNOTEL site. So a lot of times in our, like the weather only hits certain sections of the mountain. So I think that there's a little bit of a gap there with this data. But I also think that there's a huge gap between like the evapotranspiration of the vegetation and what's actually going into the soil.
Okay, so I guess along with that, so is your interpretation that the plants are bringing water and holding it in the soil because they will also be transpiring? Because it looked like you had a really high level of the 4-inch, I'm thinking of the graph on the right, had a peak, and it was in the canopy area. Yeah, and it got really high and shallow soil there, but it was high up on the slope, is that correct?
Yeah, a little part of me thinks that the water that is getting caught on our vegetation is just like evaporating before even going really into the system. Like it's kind of leaving the system before it has the chance to go into it because of just like the hot weather we get here. I don't know if that makes sense.
So you're saying before it gets to the catchment zone?
Yes.
Okay, and that's why you're measuring in the soil at that location.
Yep. Yep. And I would try to like kind of move the vegetation away and create like a little pocket where the meter would just touch the soil. So yeah, that was just kind of observation. Yeah.
So in terms of if you got a chance to get this, what would your next step be if you were able to have a little more time in the field? Like what would you want to measure or look at more of?
Yeah, I actually went back to these sites this summer to measure. I just haven't analyzed the data really. But my next step, I think, I don't know what it would be. If there was a way to see how much is evaporating or evapotranspiring. I don't really know anything about that, but that would definitely be key because there's we're like, so where's water going? Yeah.
A couple of things. First of all, very nice. Did you take photos of the site?
Yeah.
Nice to show the updated version of the presentation eventually.
Yeah, definitely.
Gives a perspective versus visual aspect.
Yeah, great.
We went from bottom of some catchment,
Mhm.
and then we walked up this. What direction was that slope facing?
I tried to keep that very similar, but most of them were different, unfortunately. I think some were east facing and then some were like southwest, so. Yeah,
I think like a south facing versus the north facing.
Would be.
Hugely different.
totally.
than Southwest. To the east of it.
Uh-huh.
And the lines on the left there, is this an average of multiple transects, or was it one measurement transect?
This was one transect. So this one was, sorry, it's kind of hard to see. Oh, I didn't write, oh yeah, this one was Buffalo Pass and this one was Flat Tops. And I believe that these two are similar elevations. And then I kind of did like two other at each. So there was 3 total at Buffalo Pass. In the same elevation as the Flat Tops, similar.
So that's why I asked you, you said the 3 Buffalo Pass.
Mhm.
Did you average those 3 between what?
Yes, or that was for. Oh, okay, this one, so I averaged them for these 2 numbers.
I see. What about going back to the other graph? And if you have 3 transects, you could add that the red line would become an average of 3.
Yeah, that's a great idea. Yeah,
Types, balance, variation types, that one you sort of right, might be some sort of a
yeah,
to have multiple samples in the same area. We sort of do this.
mhm. Are you talking about this graph or that graph?
Initially talking about the left
This one?
side graph,
Oh, yeah, yeah.
same kind of right side graph.
Mhm.
If you have multiple samples in this area, but it's artifact or some ground.
Mhm.
Thing.
Yeah. Yeah, it's totally that variable, right? Yeah, cool, thank you for that.
Any other question? Yeah, that's okay. Can you talk about you talked a little bit about some of the challenges you had during measurements, like you couldn't measure there because there was a rock and you had to figure out the vegetation to get closer, to get the probe so that they were all the way in the soil. Were there any other particular challenges that you had or problems you had to resolve in the field when you were doing the measurements?
Yes, me and Maddie walked around a lot the first day out. It was kind of hard, challenging to find a perfect slope that like kind of resembled the other ones.
Mhm.
Because the vegetation seemed to really change the amount of volumetric water content. So I was trying to keep it like all corn lilies and willows at the base, but it was almost like impossible to find those again in the same slope and the same elevation as the other sites. And yeah, there was a ton of that.
Yeah. Yeah, it's like kind of keep that as like a controlled thing where there was less difference between them, but
Mhm.
yeah, that's interesting. And then my last question, does anyone else have a question? Is just like, tell me more about why you went back this summer. Was that part of a different project or like what were the measurements and were they the exact same transects?
Yeah, I did. Actually, I messed up on one of them. I don't think that it was perfectly the same, but other than that, the other, what would it be, 5 transects seem to be like exact. And I did that because of the capstone project in for the sustainability studies program. I'm gonna hopefully compare the 2 water years, which it seemed like our summer was like super wet this year, but the Flat Tops was lower volumetric water content than last year, but Buffalo Pass was higher. So yeah, I'm just gonna analyze that. And I ended up working for the Forest Service this year and they kind of helped me out with that.
Awesome.
Yeah.
Any other questions?
Thanks so much. Yeah, thanks for the great.
Awesome. Our next presenter is going to be Clinton Alvin, and he is going to be presenting research that he did this past summer with the CWP intern. Scripts.
Sorry, Clinton, it is like super hard for me to see the screen. So I'm trying to get the.
I think that's a state, I think.
I think that would have worked as well, Rachel. And then Clinton, I'll just tell you the same thing with Rachel. It doesn't work, so just do the back and forth.
All right, sounds good. All right, yeah, so good morning, everyone. This is research that I worked on this summer with my mentor, Ming-Hua Zhang at the Center for Western Weather and Water Extremes. And we use,
Introduce yourself.
yes, sorry. So I'm an undergraduate student in the Department of Atmospheric Science at the University of Utah. Be graduating this spring, and I'm also have a minor in political science. And definitely kind of similar to what Rachel said, if you work and play in the outdoors, you start caring about water pretty fast. That's kind of the motivation behind a lot of this work, as well as so I worked on using the MODIS Terra satellite to use the cloud products in the 5-minute resolution data, which is the MOD06 channel, and we use that to characterize atmospheric rivers, and specifically one high impact atmospheric river. And the motivation behind this research was established kind of if you remember the presentation that Marty gave yesterday with the BAMS cover that had the data gaps in atmospheric rivers. That was kind of the motivation, because we have filled in some of those gaps with the dropsondes and other methods, but we still do have large data gaps, especially over the Pacific Ocean. And using remote sensing data might help to fill in some of those gaps. And that's kind of what the motivation for using this project. As well as the atmospheric dynamics of high impact atmospheric rivers are not super well understood, specifically as noted in Zhang et al. 2019 and Zhang and Ralph 2021, the relationship between an antecedent atmospheric river and a developing extratropical cyclone is not super well understood. And a specific case we're going to look at today is the October 24th, 2021 case, which was an AR scale 5, which was also the strongest atmospheric river ever recorded in October. And two research questions that we had that kind of motivated this research are how clouds are distributed relative to atmospheric rivers over the North Pacific Ocean, and specifically, how will the relationship between atmospheric rivers and these extratropical cyclones be revealed by using our cloud patch data. And again, the data we used was the MODIS 5-minute temporal resolution data, as well as the ERA 5 reanalysis data set to compare the reanalysis with the observations. And just looking up here on the right, we have this graphic. This was the AR5. This is an 18Z on the 24th. The time's wrong here. This is 2021. But if we skip forward, and if you pay attention to the top right, you'll see that we overlay the visible loop from this MODIS Terra satellite, that there is there's quite a correlation between the cloud, visible cloud fraction and the IVT maximum, but it doesn't line up perfectly. And additionally, we have this plot is from the Weather Prediction Center's reanalysis, centered at 0Z on the 25th. So from 12Z on the 24th through 12Z on the 25th of October 2021, we can see high levels of precipitation that occurred in Northern California. If any of you guys are interested, you can scan this QR code, scan a link to the California Data Exchange Center, and list the percentage of annual water year precipitation that occurred during October 2021, which is anomalously high. And for specific basins, I might note Sacramento River Basin received 28% of its annual average water year precipitation during this 1 month. And the state as a whole received 18% of its annual water year precipitation. So very high impact atmosphere. And moving into this is the ERA 5 reanalysis. We have IVT in the color fill, as well as scale here in kilograms per meter per second, as well as we have the vectors that are representing which direction the IVT is traveling. And the gray contours, if you can kind of squint, this represents our mean sea level pressure contours. And kind of the story here is, if you look in the top left, that's going to be that is 12Z on the 23rd. You see that there's a strong atmospheric river. We see IVTs in excess, maximum in excess of 1,500 kilograms per meter per second. And this existed before we see any closed contours indicating an extratropical cycle. And as we move into the next time step, that's 18Z on the 23rd, we see our first closed contour occurring at the black dot that I've outlined here, and that had a mean sea level pressure of 984 millibars at that time. And as we can see, this pressure trough underwent what's called bomb cyclogenesis, which is a pressure drop of more than 24 millibars in less than 24 hours. And you can see this rapid intensification as these contours close up, and ultimately, according to the ERA 5 reanalysis, have a mean sea level pressure of 952 millibars 24 hours after the first closed contours, which is 32 millibars in 24 hours of deepening. And again, yeah, this is the Era 5 analysis data sets. This is not observations yet. And so moving into our findings, what we found comparing the reanalysis to the observational, we have the MODIS on the cloud fraction on the left. So one of the challenges with using this data set is it's 5-minute temporal resolution, and it's not a geostationary satellite, which means it's orbiting the whole Earth. It covers the whole Earth in about 3 hours. But what that means is you have a lot of data gaps. You can't necessarily compare the same. If you're really interested in comparing, like for this event, we were kind of interested in 0Z on the 24th for this high IVT values at that time, but the satellite wasn't looking at this portion of the world at that time, so we couldn't really use this product for that application. But so we have 2 time steps where the satellite was useful, and that's 18Z on the 23rd and 6Z on the 24th. And how we created this data is we take the 5 minutes and we basically just average the cloud fraction over the 6-hour time step, centered at 60. So that's from 60 is from 3Z to 9Z on the 24th. And one of the things that I want to point out here is if you look where the circle is here, we kind of have a sag in the IVT contours, and starts with a small discrepancy where we see on the left that inside that circle we still see almost completely cloud covered, 90 to 100% cloud covered from the observational data set. But if we look at the Era 5 reanalysis, it shows that there's a gap in the clouds, and that is that same location was the center of the pressure trough that would ultimately deepen into a bomb cyclone. And as we move forward to the 60 time step on the 24th, we see that the small error has now become a large error, and what the MODIS observational had almost completely cloud covered, the reanalysis produces a large cloud free zone, which is kind of in the dry spot behind the cold front to the north of the atmospheric river and north of the IVT maxima. And if you look kind of closely, it kind of swirls around into the center of the extratropical cyclone. But yeah, again, looking at the observational data set, we don't see that anomaly. So we think that as a result of this, the Era 5 reanalysis data set is underrepresenting the total cloud cover, and specifically where cyclogenesis is occurring. And some future work that we want to do, because we only looked at one specific high impact atmospheric river for this case study, is creating a composite data set adding in a couple more variables, including cloud top phase and cloud top pressure, and create this for 2 atmospheric river seasons, which should be in excess of 200 atmospheric river events. And hopefully for creating a composite, so we want to know what does the average atmospheric river look like? Where are the clouds oriented relative to the average atmospheric river and average extratropical cyclone in the Northeast Pacific? And that is hopefully the subject of the future paper and future data set that we create. Thank you for your time. I'll take it back.
Looking at the satellite data, so you noted for this, is there a space for like the geostationary satellites to go back, or is that data kind of an observation course for this sort of?
It's kind of 2 cores. One of the challenges that I could have mentioned is that, I mean, atmospheric rivers occur on these large spatial scales, but a lot of these small scale features occur on very small temporal scales. So even with MODIS, most people, because data is heavily underutilized, most people use the one day average cloud fraction, because then it doesn't have these gaps like this. It's a little easier to work with. But I mean, if you're looking at 1 day average, atmospheric rivers could have a lifetime of just 12 hours. And so you're going to miss a lot of these smaller scale features with that kind of coarse resolution.
Thanks.
Yeah.
I hesitate to ask this, but really not a meteorologist. Give a little context. What are the factors that are leading to the formation of the AR and is one leading to the other, or are they just created by the same dynamics in the ocean?
Yeah, so that's the paper I mentioned, Jang and Ralph, Marty's paper.
Which one did I?
Yeah. Yeah, the thinking is that the antecedent atmospheric river, if I go back to the previous slide, I mean, we see here, so the definition of an extratropical cyclone is we have closed contours, and we don't have any of that. So that means there's no extratropical cyclone relative to this atmospheric river at this time, but we do have a large quantity of IVT. So yeah, the thinking is that the atmospheric river antecedent to the extratropical cyclone, they kind of feed off each other. That I mean, it's a lot of latent heat available to help deepen that extratropical cyclone. Yeah.
Did I expand on that?
Yes, of course, yeah, sure, I can like hit that.
That upper left diagram, if you could then point to the top order, you see there's the
Yeah.
use of the row
Yeah,
there.
yeah.
That's so far away from the AR, it's got the dark circle around it. That we don't consider that to be, they sort of coupled with that, right? However, that area where the AR is, and that's actually an exceptional AR, strong as a
Yeah.
term. It's just 1500.
Oh, yeah, that's
all
technical.
intensity. That that AR you see there is a remnant of what that cyclone off page now created like the day before. And now, because of the way the dry dynamics of the atmosphere is, another cyclone starts forming, where you see the black dot here. And it happens to form. It doesn't have to have an AR. Only like a third of cyclogenesis events have an AR already in their name. So that literally supercharges the cyclogenesis.
So there's some chance, but they're not necessarily the cause.
In this case, it's specifically that the start of the second cyclone there
Yeah,
was likely not because of that, but the rate at which it defect was accelerated because of it. And I'm going into this a little bit deeply because like that. And the media was all over this, with the bomb cyclone. So they said the bomb cyclone caused the AR that caused overheat at that point. But the reality is the pre-existing exceptionally intense AR supercharged a cyclone to become a bomb. And then the present while the AR.
Yeah, and just expanding off of that, I mean, I don't know the statistics off the top of my head, but to have a bomb cyclogenesis occur not only in this region of the world, but at this low of latitude is quite anomalous. And so that's as a result of the high or the exceptional atmospheric pressure.
Great cases. We're gonna.
no, exactly. I actually understood.
It's like, all right. Any other questions?
Just thinking about the impacts of such things, then you said like this amount of water, was it a relief or a major concern?
Concern. I mean, once you get an atmospheric river, that's like AR scale 4 or 5. I mean, flooding becomes the main concern. It's much less of a beneficial AR and much more of a harmful AR, I want to say.
Little bit, the distinction here, the flooding that happens is like local flooding.
Yeah.
Small rivers, the big rivers is flood out.
Yeah,
Because the landscape is flowing dry.
yeah, this is the first big storm.
And the person who ran the forecast on the rivers in California, in the back corner, correct our, who's here.
Yeah. Yeah, I mean, what's going on?
There was some local runoff, I have a property to burn on the lookout. Some, well, it isn't right. Real river on the side. Then we got like 6 or 7 inches of rain.
Mhm.
It's the wettest single day in Sacramento's.
Yeah, I didn't include them in this shorter presentation, but I mean, there was like landslides on California Highway 70 that close to the road for multiple days, lots of flooding in the northern Sierra. But yeah, not large scale river flooding, just local stream. Any other questions? Thoughts? All right, thank you.
Thank you for that, great presentation to David. Our next presenter is going to be Lily in Sakota. Lily conducted the CWC YBSC Colorado Mountain College internship with Scripps this past summer. And we're so excited to have Lily present.
Hi, I'm Lily Svoboda. I'm a junior here at Colorado Mountain College. I'm studying ecosystem science and stewardship. I love the outdoors. I think growing up in Colorado, pretty much everyone loves and cares about the nature here. And I guess a little fun fact is I actually run the beekeeping club here at the college, which is really fun. Really enjoy that. And so, yeah, I'll get with my presentation. So I did the analysis of variation in soil moisture in different affected forest areas here in Route County. So my research question was, how do in situ soil moisture measurements provide insight into the impacts of how different forest treatments affect soil moisture? So if you can click to my. Oh, sorry, no, my bad. So sorry. So sorry. I'm so used to not doing it. Yeah, so for this, I used a handheld soil moisture meter. And I used two different probe lengths. Like Rachel, I used 4.8 inches into the soil and also 8 inches. It's really hard to see. So yeah, for my first site, I did MWW treatment plant, water treatment plant, which is just kind of over here, back here by history.
Maybe easier if you come on the side if you want to,
Sounds good.
just see what you
Oh,
think.
yeah. Okay, so I have an image here of the masticated site, and when an area has been masticated, that means all of the trees are shredded down. It leaves a really woody mulch on the surface, no tree cover left over. So you can see that here, lots of organic debris. And then for each site, I used a control site nearby. Unaffected, I tried to get as close as possible so there wasn't major changes in elevation or, tree cover. Well, yes, tree cover for this, but sorry, different types of vegetation. So there wasn't any differences in vegetation as well. And I tried to get the same aspect for the treatment site and the control sites. So for the treatment plant, my masticated site, I did 3 different consecutive transects that were each 10 meters long, so a total of 30 meters testing sites. I did 3 replicates of soil moisture testing every 3.7 meters. So this was a total of, if I can remember, about 27 measurements for the 30 meters. Just a little bit of orientation for this graph here. The testing was done in volumetric water content, which is just the ratio of water to soil. So we have that here, and then these are my sampling locations. So this is the averages of every transect. So like I said, there was 3, they were 10 meters long. So here you can see I have the control site is the blue and the orange, and then the gray and the yellow is the masticated site for the different depths. So you can see this gray here is the masticated short depth. So this is 4.8 inches, and you can see it has a much higher volumetric water content compared to the control sites for this, as well as the deeper depth. So I did t-tests for my data to see if there's significant differences between the masticated site and the control site. And the t-test concluded that the masticated site retained a significantly higher volumetric water content, higher soil moisture at the 4.8 depth. So you can see that here. This scale, or this graph here, just shows the larger scale soil moisture variation. So this is the average for my controls and masticated. So this is the significant data right here. And it concluded that there wasn't a significant difference in volumetric water content for the 8-inch depth. So my second site was Buffalo Park, which if you go on Rabbit Ears Pass, there's a turnoff and you drive back for about an hour and it's back there. So for this site, this was a wildfire site, happened a couple years ago. And then this is my control site. Again, tried to get as close as possible in the different areas. These were taken on the same aspect, same elevation. You can see the wildfire, there is vegetation growing back, but not as much tree cover here as in my control site. There's a few standing trees, but there was a lot of organic debris on the ground. So again, here, these are the averages for those 3 transects taken. And you can see again, the blue and the orange is the control site, and the gray and the yellow is for the wildfire site. And so the t-test for this site concluded that the control site, so the area that has not been burned by wildfire, retained a significantly higher soil moisture. So the control site had much more or a higher volumetric water content than the wildfire site.
So the site that didn't burn.
And then, so my third site was the Colorado State parcel, kind of over by Yampa area. This was a patch cut site. So you can see here, a lot of the coniferous trees have been cut down. Some of the aspens are starting to shoot back up. There was some vegetation that was growing back. And then this was my control site nearby, way more tree coverage, just much more natural looking landscape. And then so same thing for this. One thing to note here is that this patch cut site, I had some troubles with taking some measurements because it was so rocky and dry. So I have 1 point here for that, just to showing the averages. And then again, so the control site, much higher volumetric water content compared to the patch cut site. And so my results for this site concluded that the control site at the 4.8 inch depth was had a much higher volumetric water content or soil moisture at that depth, but did not for the 8 inch. That was not significant. And yeah, that's all I had time for this the presentation. Yeah, thank you so much. Sorry, does anyone have any-
Did you say what time of year?
Yeah, so this was this summer that I took these, and so these were all taken in July of this year. Yeah, over the course of a couple weeks.
You bring up a very naive question, so I'm not going to force your background, but what would be the context where we would see the mastication? Why is that done? Is where the trees cleared out, or have they already fallen or burned? What's going on?
From my understanding, it was for fire mitigation, so to create a break in the forest. Yes, so I can go back to that picture. What is this? Yep. So yeah, as you can see, there's in the background tree standing, but there was probably about 100 yards by 100 yards where it was just no tree coverage at all, very open to the sun. This was actually done in spring of this year, so some of the vegetation is growing back, but there was so much organic debris and like mulch over the surface, and I believe that's one of the reasons why that at the shorter depth it was such like a higher volumetric water content, is because it kind of created a layer to keep that moisture in. But yeah, this was my one significant test where the treatment site was had a higher soil moisture than the control site.
We have an estimator and chief.
Yeah.
Well, so I'm Carolina with the State Forest Service, and we did this project at the Mount Warner water plant. And when we do mastication, I mean, we are masticating trees, but these are oaks. And I don't know if you've seen a gamble oak is on average 15 to 20 feet tall. They look more like shrubs than trees. We wouldn't go in and masticate the forest like a standing Douglas fir forest that you see right there. This is for kind of scrubby mountain shrub types. And as she was describing, it's just mostly break the continuity and renew that forage. It plays both a wildfire risk reduction and also a habitat enhancement role. So because it resprouts really heavily, and that's why our game really likes to eat. It's that new growth. And I'm glad to see these results, because obviously we use mulch for water conservation, and we hope that that mulch, again, depths, our prescription said depths, 4 to 6 inches tops for that mulch layer, because we do want to allow for that pre-growth to happen. And so again, yes, it's just for certain types of vegetation that we use that particular treatment. If there's a lot of dead and decaying aspens, we might do mastication if they're small, kind of marginal in size. But we're not really using this for major forest.
Yeah, this was the one area in Routt County where I could find investigation, so it's not used super commonly here.
And though, I mean, oaks are trees and we can call them trees. But when we talk about trees, we usually think of,
Yeah,
like a Doug fir or spruce, like oaks are, we call them trees, but they're kind of strong ones. Our oaks and we're strong trees. But this is great. This is, and actually the other side we did, I was very curious about the third study site. And I'm just wondering how you went about deciding where your transits were, like, was this, you got the map of the treatment units and you randomly set up your transit sites? I mean, the topography of that parcel is so complex, and how the water moves through the parcel is so complex.
Yeah.
And we built obviously a few roads to get there, and there's obviously compaction in some places and a lot of aspen region in places. So
Mhm.
again, how, and we can talk later too, but how did you go about picking your transit locations?
yeah, so when I was looking for sites, what I did is I looked at areas over maps just to see what areas that I could find for the different treatment areas. I consulted with Tim about what he knew about different treatment areas. I actually had been to this area before when we were scouting sites for the network. So I had been familiarized with this area. So I knew this is somewhere where I really wanted to go, because it was patch cut. But when actually determining the site, something I really wanted was the affected area being as close to a control area as I could get. So I think Maddie and I on this day, we looked around for an hour or two, just trying to find a good site where we could see it had obviously been patch cut, signs of that, but also this area nearby. So I really didn't want any major differences in elevation or aspect or anything. So that was how I really determined like specifically what area. The goal of this project was to examine the affected area compared to a control area instead of comparing necessarily different treatment types to each other. So that's kind of why I didn't make any comparisons between, oh, mastication is better than patch cut for keeping in soil. That's not what I was investigating. It was more like control versus treatment.
Yeah. No, I appreciate this. You should come present it to my office. This is important, so thank you.
Yeah.
I do want to talk to you.
Okay, sounds good.
Thank you.
Yeah, of course, thank you. Is there anyone else? Yeah.
I was just wondering how old was this burn area?
I remember I looked at it for my report and it was, I think it's been three years. I was gonna say it's less than 5 for sure. Yeah.
Is it south?
Yeah, I was thinking you could,
Perfect. Yeah.
South of the Travelers Pass.
Yes, it's
Road.
like,
Highway 40.
yes, it's, yeah. It's west. Yes. Did you have a question, Kim?
No, I think I'm good.
Okay, sounds good. Thank you so much.
Awesome. Well, I would just want to say thank you so much for presenting today. It was wonderful to hear your work and your contributions to CW3E and our local community here. And it's awesome to have some partners in the room. And as we have heard from Darlene, this work is really valuable. And so thank you for your contributions. I did want to note that we asked these presenters to give really short talks today. So thank you so much for slimming down your information and just giving really critical short talk. That was awesome. And I know you probably could have gone on a lot longer. So thank you for that. And I just wanted to say that this is a great connection to our theme this year for the entities surrounded, which is CPS observations for water resilience in the Upper River Basin. We heard from some work that's been done in California and then here locally again too. So it's just great to hear all these perspectives. And thank you so much.